Your FastMCP server is running, but how do you actually test that Google OAuth Authentication works end-to-end? You'll see exactly how to build a client that automatically handles the OAuth flow, opening the browser for login, securing tokens, and making authenticated requests, all in just a few lines of code. The pattern even caches credentials locally, so you won't need to re-authenticate every time. From FastMCP Import Client. Import Asyncio. Async def main. Hash the client will automatically handle Google OAuth. Async with client. http://localhost 8000/mcp auth equals OAuth as client. Hash first-time connection will open Google login in your browser. Print authenticated with Google. Hash test the protected tool. Result equals await client. Call tool. Get user info. Print F Google user. Result email. Print F name. Result name. If name equals main. Asyncio run main. This demonstrates the OAuth proxy pattern for integrating traditional OAuth providers with RPC frameworks. The pattern bridges the gap between OAuth 2's browser-based flow and programmatic client authentication, enabling secure access to protected endpoints without manual token handling. What makes this distinctive is its ability to maintain stateless server architecture while supporting stateful authentication flows. The approach works by externalizing the authentication complexity to a dedicated provider layer. The client initiates the OAuth flow through a context manager, which automatically handles token acquisition, storage, and refresh, while the server validates tokens via the provider's standardized interface. This separation of concerns allows both client and server to remain agnostic about the specific OAuth implementation details. This pattern solves the common problem of securely integrating third-party authentication with custom RPC systems. It eliminates the need for manual token management in client code while maintaining clean separation between auth logic and business logic. The trade-off is increased initial setup complexity, but the result is a maintainable system where authentication can be swapped or upgraded without affecting core functionality. Let's break it down line by line. From FastMCP Import Client. Imports the client class from FastMCP, the primary interface for connecting to MCP servers. This handles all low-level connection management, authentication, and tool invocation with a clean async API. Import Asyncio. Imports the Asyncio library, Python's built-in framework for writing concurrent code using async await syntax. This enables asynchronous operations like network requests, which is essential for non-blocking communication with the FastMCP server. Async def main. Defines an async entry point. This is the standard pattern for async scripts, allowing await calls inside. The event loop executes this function when the script runs. Hash the client will automatically handle Google OAuth. Async with client. http://localhost 8000/mcp auth equals OAuth as client. This establishes an authenticated connection to the FastMCP server using Google OAuth. The context manager handles both the connection lifecycle and automatic token refresh, while the auth equals OAuth parameter triggers the browser-based Google login flow. This pattern ensures proper resource cleanup when the block exits, preventing connection leaks. Hash first-time connection will open Google login in your browser. Print authenticated with Google. This confirmation message signals successful OAuth completion. The browser-based Google login flow has finished, and the client now holds valid credentials for authenticated API calls. This pattern is common in OAuth implementations where the initial auth handshake happens externally.
Hash test the protected tool. Result equals await client. Call tool. Get user info.
This invokes the protected getUserInfo tool via FastMCP's RPC system. The await handles the async response, while the client automatically includes the OAuth token for authentication. This pattern keeps tool calls clean while ensuring secure, authenticated access to server-side functionality.
Printf Google user. Result email.
This extracts and displays the authenticated user's email from the tool response. Verifying the email confirms the OAuth flow succeeded and shows which Google account is active in the session.
Printf name. Result name.
This extracts and displays the user's name from the Google OAuth response. The result dictionary contains the authenticated user's profile data, and this line specifically accesses the name field to show it in the output. It demonstrates how to work with the structured data returned by FastMCP's protected tools.
If name equals main.
This is Python's standard entry point guard. It ensures the async event loop only runs when the script executes directly, not when imported as a module. Without it, importing this file would immediately trigger the OAuth flow and API calls.
Asyncio, run main.
This boots the async event loop and executes main, the standard entry point pattern for async Python scripts. Without this, the coroutine would never run, as async functions require explicit event loop management. OAuth Client Integration Pattern. This client demonstrates FastMCP's seamless OAuth integration, where authentication becomes invisible infrastructure while maintaining full access to user identity claims through standard tool calls. The cached token silently handles subsequent authentications until expiration, which can cause confusion when debugging permission issues after initial success. Always verify your token claims match the expected provider structure before building dependent logic.
The client that forgets to authenticate remembers everything about you.